Lesson 6.6 Conduction. Conduction is the process where heat is transferred through a material without any movement of the material. So heat just moves through some object, or from one object to another when the objects are in close contact with each other. This often happens when the energetic hot molecules bump into less energetic cool molecules. Remember, the molecules are constantly moving, and more motion means more energy at a higher temperature, more kinetic energy at a higher temperature. So those higher energy molecules bump into the lower energy molecules and transfer energy, so that the other molecules are now moving faster, have more kinetic energy, and a higher temperature. So this happens through bumping into things and transferring kinetic energy. Thermal conductors are materials that conduct heat well, such as metals. Thermal insulators are materials that conduct heat poorly, such as wood, plastic, and glass. So the conduction of heat through a bar is Q over T. So this is the rate of heat conduction. So that's a rate of heat transfer is K, which is the thermal conductivity constant, not Boltzmann's constant. It's in a table for each of the different materials, times the cross-sectional area times your difference in temperatures over the length of the bar. So there are two ways to create good insulators. Have a small K and a big D. So small conductor and a large distance. This D over K is called the R factor. And when you buy insulation, you'll see that they're rated by R factors. The higher the R factor, the better the insulator. Other insulators like goose down and Styrofoam work by trapping air in small places where convection currents cannot arise, and air is a good insulator. So how much heat is transferred through the Styrofoam insulation, the walls of a refrigerator, in an hour? The total area of the walls are about 4 meters squared. The Styrofoam is 30 millimeters thick, and the temperature inside is 5 degrees Celsius, and the room temperature is 25 degrees Celsius. Well, Q over T is K, a T2 minus T1 over D. We're looking for Q, and it's in an hour, so our time is 3,600 seconds, which is 1 hour. It's Styrofoam, so the K is 0.01 joules per second meter degrees Celsius. Our A, it says, was about 4 meters squared. Our temperatures are 25 degrees Celsius and 5 degrees Celsius. And the D is 0.03 meters. 30 millimeters. If we convert it into meters, you have to move the decimal 3 places, is 0.03 meters. So you multiply by the 3,600, and you get 96,000 joules. Seems like a lot of heat. That means your refrigerator has to move that much heat the other direction to keep everything cool inside. A major source of heat loss from a house is through the windows. Calculate the rate of heat flow through a glass window that's 2 meters by 1.5 meters in area and 3.2 millimeters thick. If the temperature on the inner and outer surfaces are 15 degrees and 14 degrees Celsius respectively. All right, well, Q over T is Ka T2 minus T1 over D. All right, so we're looking at the rate, so we actually want this Q over T. That is the variable we're solving for. Glass, K is 0.84 joules per second meter degrees Celsius. Our area would be 2 meters times 1.5 meters. And our temperatures are 15 and 14 degrees Celsius. The thickness of the window is 3.2 times 10 to the negative 3 meters. Run that all through the calculator, you get 790 joules per second. So the heating system of your house has to produce 790 joules every second to keep your house warm just from the heat loss through that window. Remember to conduct yourself as Christ-like. That's it for today. Have a good day.